we need to find the directional derivative of this function. F of x comma y is equal to xy plus 2xy squared plus 3x cubed y at the point negative 2, 4, and in the direction of the vector v is equal to I minus 2j. Now, we need to remember the steps that we're going to take in finding directional derivative. Remember also that the directional derivative is a scalar, and the directional derivative at a specific point in the direction of the vector, what it measures is the rate at which the function changes as you move from that point in that particular direction. All right? Now, remember the steps. Step 1. And before we look at step 1, let's look at the overall formula. The way it is written, directional derivative of u, which represents the function fp of a function p, or u is the not the function, u represents the unit vector. This is how it is generally written, right? And fp, that's the directional derivative. It is equal to the upside down triangle f. That means the gradient of the function at that point, all right? And the point is p dot u, all right? If I was typing it, it would be bold, but let's put a little hat over u to show that it is not just a vector, it is the unit vector, all right? So it is the dot product between the gradient of the function at the point P and the unit vector in the direction of P. Alright? Now, you can call this step 1 if you want. Write down the formula. Now, in step 2, you're going to find the partial derivatives. Alright? Now, in order to find the gradient of the function, the upside down f, what you're going to do is find the partial derivatives. So in this case, you're going to have delta f of the function by delta x plus delta f by delta y. All right. Now, that is the gradient of the function. All right. So, I should say the gradient vector of the function, not just the gradient, because it's going to be a vector. So I should put in I and j. Now remember, another way to write the vector is to use the angle brackets, delta f by delta x, comma, delta f by delta y. You might see that notation some of the times. Same thing, right? Same as this. And this could have been written like that too. It could be I, comma, negative 2 in the angle brackets, right? So it could be not I, 1, because it's 1I. So 1, comma, negative 2 in the angle bracket, right? Same thing, it's just another way of representing the vector, all right? So you're going to find the gradient vector. Now, step 3, you're going to substitute x naught and y naught into the gradient vector. You remember what I call x naught and y naught? Or I could say x0 and ground 0. That is where you start the movement. And that movement starts right here, right? So x0, or called x0, is actually negative 2 and y0 is 4, all right? Now, once you do that, remember you're going to have the dot product between the gradient vector at that point and the unit vector. And of course, you could remember that particular step, don't forget it, because it's like, or you can compare it to multiplying two numbers, the dot product of two vectors. If you compare it to multiplying two numbers, if you multiply a number by 1, you get back that same number, right? And 1 is unity, this is a unit number. It might look different. For example, suppose your 1 is 2 divided by 2. That's still 1, you know. And it will look different, but it doesn't change the value of the number. Now, if you that product a vector by the unit vector, it will look different, but when you compare it to the numbers, it doesn't really change the value. So remember to use the unit vector, not the given vector, all right? So you substitute. All right, let's call it step 4. You find the magnitude of V and divide V by it. Remember, even though I put this in step 4, you could even have started by doing that. You could have had it at step 1. Doesn't really matter, all right? So this will give you the unit vector. Dividing a vector by its magnitude will give the unit vector, all right? Step 5. You dot product both of them. So now you remember all the steps. I want you to write these down and pause or stop the video. Go aside and work it out. Then come back and finish watching the video. Okay, you're finished? What did you get for the directional derivative? Let us see what's going on here. So let us have step 1. Let me just draw a line here to show where we start. We start at step 1. So you write down that the UF of P, right? That's the directional derivative in the direction of the unit vector at the function at the point P is equal to the gradient vector dot unit vector. You see that? Now, let us go to step 2. You're going to find the gradient vector, which is delta f by delta x I plus delta f. I don't know why I write a delta like that. So it's the partial derivative of f with respect to x in the I direction plus the partial derivative of the function f with respect to y times in the direction j. Alright? So what are these? Partial derivative of the function with respect to x is equal to, alright, we have to look at the function. We're going to have a y here. You have to remember your differentiation. You have y. Then this is going to be 2y squared plus 2y squared plus 3x cubed. Alright? Now, at, what was it? At negative 2, 4. At negative 2, 4. Delta f by delta x is equal to. So, x is negative 2 and y is 4. So we're going to have 4 plus 2 times 4 squared plus 3 by negative 2 cubed is going to be 4 plus 4, 4, 16, 16, 2 is 32 plus and negative 2 cubed is negative 8. It's going to be a minus negative 8. H is 24. Alright? I'm going to use my calculator off the air. But you, of course, should have your calculator and verify everything. But you should have completed the question already. I'd asked you to do that earlier. So what I have is 4 plus 32. That gives me 36. Minus 24 gives 12. This is equal to 12, right? Now, what about delta f by delta y? Well, delta f by delta y. X plus, so we're going to have x plus, and here we have 2 2's 4, so it's going to be 4xy plus 4xy, then plus 3x cubed plus 3x cubed. Alright? Now, at the point negative 2, 4, what is it? Delta x by delta y is equal to, x is negative 2 plus 4 times negative 2 times y is 4 plus 3 times negative 2 cubed. That's negative 2 plus, well, it's going to be a minus because it's 4 times negative 2. So that's minus 8 by 4, which is 32. So 4 times negative 2 is negative 8. Negative 8 plus 4. Not there, negative 8 times 4 is negative 32. Alright? It's going to be minus 2. 2 2 is 4, 4 2 is 8, 8 3 is 24. So, what I have is negative 2 minus 32 minus 24. Alright? And let me calculate that. $58. So that is 58. Negative 58. Alright? So we have these. So therefore, the gradient vector is equal to 12i minus 58j. 12i minus 58j. Alright? Now, that is the gradient vector at that point that we're given, negative 2, 4. Now we want to find out what is the unit vector. So we're at step 4. No, step 3 was to substitute. Yeah, we had done step 3. Alright, step 3 was here after we do the substitution. So now, step 4. Let's write that. Of course, in exam, you would need to be writing step this and step that. This is, I'm writing here because it's a matter of helping to remember the steps. Now, you're going to find the unit vector. The vector, the vector whose direction the movement takes place. V is equal to I minus 2j. Let me rewrite it. V equal to I minus 2j. Alright. Now the magnitude of V is equal to, I'm writing sideways, going to the right because I know that there's limited scrolling space downwards. Don't want to reach there too soon. Alright. It's going to be the square root of. I remember in a previous video I showed you the reason why you have a square root and so on and so forth. It's because the I is horizontal and the j is vertical. So when you're finding the magnitude, is really the hypotenuse of right angle triangle, right? So in this case, it's 1 square root of 1 squared plus negative 2 squared equal the square root of 1 plus 4 equal the square root of 5, right? So that is the square root of 5. So therefore, what we have here, the unit vector let me just, oh no, what am I doing here? Hold on, why is it still? Alright, okay, we're back on track. The unit vector, not a line, it's a hat. Let's call this step, oh, we're still at step 4. So the unit vector is going to be I minus 2j divided by its magnitude, square root of 5, which means I divided by the square root of 5 minus 2 divided by the square root of 5j. Alright? Now, let's go to the next step. You're going to find the dot product of these two vectors. Alright? So, here, what we have, the gradient vector, is 12i minus 5j, or referring back to the formula, it is the gradient vector dot unit vector. So let me write that. Gradient vector dot unit vector. Gradient vector of f of p at p, the function at p, times the unit vector. Alright, so here now, the gradient vector is 12i minus 58j. Alright, remember duf of p is the symbol we're using. The directional derivative in direction of the unit vector, right, of the function at the point, the given point p. Remember that what this means, alright? So it's going to be the gradient vector of p dot unit vector. So here, the gradient vector, what was it again? 12i minus 58j dot 1 over square root of 5i minus 2 over the square root of 5j. I'll separate the numbers on the i's and j's here, because it might be easier to see what's going on in that case. And remember, it's going to be a vector, a scalar, right? I times I plus j times j. So what we have here is this is equal to 12 times 1 over square root of 5, right, plus negative 58 times negative 2 divided by square root of 5. Alright? So, what you have? 12 over the square root of 5. Now, oh, why did I put a minus? Maybe it's went there by a mistake. Oh yeah, right, it's not a mistake. I just remember. You have a negative 58 times negative 2 over square root of 5. Alright, so it's going to be a plus then. 58 times 2 is what? 2, 8, 16. You know, the 6 carry 1, 2, 5, 10, and 1, 11. Is 116. Alright? Over the square root of 5. Now, this is equal to something over the square root of 5. If you remember your fraction, you just add these numbers at the top. 6 and 2, 8. 1 and 1, 2, 1. 128 divided by the square root of 5. Now you can leave it that way, but suppose we work it out. 128 over the square root of 5 equal 57 point something, right? Around 57. So let's say 57.2. 57.2 is the directional derivative of the given function. Alright? So let's just review quickly. So we have the steps when finding directional derivative. You write out the formula. It's the dot product of the unit vector and the gradient vector. Step 2, find the gradient vector by differentiating each quantity, which is differentiating the function with respect to each quantity. Step 3, you substitute the coordinates at the point x0, y0, and you get your gradient vector. Step 4, you find the magnitude of the given vector and divide the vector by its magnitude to get the unit vector. Then of course your dot product, the gradient vector. Find the dot product of the gradient vector and the unit vector. Alright, so I'll see you in the next video.